All right, Math 30s, here's a little video that we're going to show you some methods and sort of some ways in order to help you move through these trig identities. And one thing I find that helps first and foremost is to have your formula sheet with all the trig identities right next to you when you do this. The other thing that I do want to point out is whenever you see functions in brackets here, so like sine pi minus x minus tan pi plus x, usually this is sort of an indicator that we're looking at a form of identity or a trig identity that can be expanded and used. So what I'm going to do here first is look at our formula sheet and see if this does in fact belong to an identity. And when we do that, we actually see that both of them do. And I'm going to expand both of these identities in hopes that they're going to resemble something on this side over here. So I got sine pi minus x really belongs to the identity of sine a minus b. And what we got to understand is that the pi would represent the a and the x would represent the b. And so this identity breaks down as follows. Sine a minus b is equal to sine a cos b minus cos a sine b. And with regards to our function here, we're going to rewrite this to something more relevant to our problem, which is sine pi cos x minus cos pi sine x. And so that's the first identity expanded. Now I'm going to do the same thing with the tan. And then, like I said, when we look at our formula sheet, we do see that it is an identity. It's a sum identity more specifically. So again, this is the A, this is the B, and this would separate into, and I'll write it into red over here. That'll be, so tan bracket A plus B is equivalent to tan A plus tan B over 1 minus tan A tan B. More specifically, I'm going to erase these here, and instead of putting A's and B's, I'm going to replace them with pi's and x. So we're going to write pi and then x and then pi and x. Now, all I've done here is actually just look at the left side. And so that comes to the second point. The way I approach these is I do the left side first, and then I do the right side if it can be simplified. So right now what we're going to do is just focus on the left side. Here's the left side of the identity. Okay? And at first, when we look at this, we're like, well, this is, there really doesn't seem to be anything that resembles any of these on my formula sheet that I can break down. The thing is, remember that pi are actual values. If you think about the unit circle, you have 0, you have pi over 2, you have pi, and you have 3 pi over 2, and then, of course, 2 pi. And additionally, we have our cosine value and the sine values at each of these extravagant ends of the graph here, or of the axis. So remember that it's 0 and 1 over here. Or sorry, 1 and 0. Let me fix that. It's 1 and 0. And it would be 0 and 1. This would be -1 and 0. And this would be 0 and -1. And that these are x's and y's true, but more specifically, these are cosine values and these are sine values. Well, let me write that a little better here, sorry. And so a couple of values stick out here. If this is the sine and this is the cosine, then sine pi over here is really just 0. Furthermore, so this I can actually cross out and put 0. And cos pi, or the value of cos at pi, is -1. So I can actually cross this out and put -1. Now what I'm going to do is, with that in mind, I'm going to rewrite this entire left side. And since we know that sine pi is actually 0, then this whole part of the equation would just be equal to 0. And so we could rewrite this as 0. And then since cos pi is -1, we can just write 0 bracket -1. And then all we're left with is sine x. Now at the same time, when we look at our quadrant, remember that tan is just sine over cosine. And so when we look at tan pi, we can see that it would just be 0 over -1, which is, well, it's just 0. So that would also become 0. And in fact, so would all of this, because tan pi would be 0, and 0 times tan x would give us 0. So on this side of the equation, or this part of the left side, we would have minus tan x divided by 1 minus 0, which would really just be tan x over 1, or tan x. And so, to put this simply, if we add both of these here, we would have sine x minus tan x, and this is the left side of the equation. Now we're going to go ahead and do the right side of the equation and see if we can get it to equal sine x minus tan x. So I'm going to draw a line here. We're going to do the right side. And we're going to go, and I'll write it here. Whoops. We're going to go sine x cos x minus 1 divided by cos x. And there's a couple of things that we can do here. Now, right now, if I include the left side, it currently equals this, right? This thing that I boxed at the top. So what I can do is, if I look over here, sine over cos is really just tan. So simplifying this, I can go tan x multiplied by cos x minus 1. And that would fulfill the tan x portion of the formula. But we have to expand this and remove the brackets. And we're going to remove the brackets by doing distributive property, or FOIL. So tan x times cos x gives you tan x times cos x. And then tan x multiplied by -1 gives you minus tan x. And so we completely have this part of the equation right over here on the left side. Now this tan x times cos x, if you remember that tan is equal to sine over cosine, well, if you isolate for sine, whoops, we would cross multiply the cosine, and tan times cos would equal sine. And so tan times cos, well, I could just replace this with sine x. And then now the right side also has sine x minus tan x over here. And more importantly, we have that the left side equals the right side. And the equation is proven. Now, In our next video, we're going to look at another problem, so stay tuned and click